We are recording the meeting. If that is okay with y'all, let us know if you have an issue with that in the chat. And Anna, do you want to
Yeah.
take us away?
Thank you so much, Cody. All right, welcome everyone, and thank you so much for coming. My name is Anna Weiss. I'm the Community Science Program Manager at the Billion Oyster Project, and I'm joined today by Cody Herman, our Community Science Technician. And we're so excited that you're here for our Lunch and Learn. Today, we're going to be talking about our Community Water Quality Testing Program, a little bit about what it does, why we do it, and then we're going to talk about the results that we've seen so far for 2023. Next slide, please.
Sorry. Where? Immediately lost it. Okay.
Thank you. So just really briefly, what we're going to cover today, we'll talk a little bit about what impacts water quality in New York City and some of the folks that do water quality testing. We'll talk specifically about Enterococcus testing, what that is, how it works, and what it tells us about water quality. We'll talk about some of the data we've collected this season and give everyone an opportunity to check out the results from their favorite water body. And then we'll talk a little bit about what you can do to get involved with community water quality testing and just getting cleaner water in New York City in general. So we will have a lot of opportunities. We're going to stop along the way to ask folks for questions, at which point you can raise your hand. But if you do have a question and you don't want to wait, you can always pop it in the chat and we'll try to answer it. So those will be our two sort of mechanisms. If you have a question, we totally welcome them. So please ask away. Next slide, please. So what is water quality? When we say water quality, we can be talking about a lot of different factors and a lot of different things. Everything from the amount of oxygen and other types of gases in the water to the amount of nutrients like phosphorus and nitrogen. We can talk about how clear or turbid the water is. And then there's also factors like pollution. So floatables, oil, industrial waste, and then even nuclear pollution. Today, though, we're going to talk about one very particular type of water quality or one type of measurement of water quality. And this is Enterococcus. And I'm going to let Cody go ahead and explain what Enterococcus is.
Yeah, thank you, Anna. So Enterococcus is a bacteria that lives in the intestinal tracts of warm-blooded animals. So that's humans, that's birds, other mammals. It is a fecal indicator. So when you get tests that show Enterococcus, you know that there's typically poop and other fecal bacteria in that sample. And this matters because fecal bacteria can be harmful to humans, to human health, and specifically in our context, it really prevents safety around primary contact in our waterways. So how does Enterococcus get into the water? Through our sewage system, actually. So during dry weather, the way that New York City's sewage system works, you typically would flush your toilet. It goes into one pipe underground. Any runoff from the roadway is going into one pipe underground, and that gets put out into the wastewater treatment plant where it is treated and then put back out into the harbor as clean water. During wet weather, you have rain falling on the street, which goes into the catch basin, combines in the pipe with your wastewater from your home, and it overloads our wastewater treatment plants and the pipes within our sewage system. So then you have untreated sewage, raw sewage from your home, and stormwater runoff from the streets coming out of combined sewage overflows, as you could see here on the right side of the screen. Enterococcus also ends up in the water, not only from human poop from the sewage system, but also from geese, defecating along the shoreline. And if you're not picking up dog poop on the sidewalk, the next rain is going to come and take that fecal bacteria right into our storm system. So it's really a wastewater and a stormwater problem. About 60% of New York City has a combined sewage system. And that means that raw sewage and stormwater is expelled through about 450 combined sewage overflows during wet weather events. And that is coming from about 60% of New York City's area. As climate change increases, or the impacts of climate change increase, and we see more rainfall, we're going to see worse Enterococcus numbers in the harbor. We're going to see more combined sewage overflow pollution. And with increased population density in New York City too, we'll also have more people flushing their toilets during those wet weather events, which will lead to increased bacteria concentrations in our harbor. The impacts of combined sewage overflow, the one we notice the most is probably unsightly sites, kind of like in the bottom right here pictured, and smelly water. So those type of things happen because of the introduction of pathogens and toxins to the water, as well as debris from litter on the street. And that really impacts the waterways for recreational users. And even if people, want to go out and visit their waterway, if you notice that smell, if you notice debris in the water, it's really kind of discouraging. In some cases also, we find that there are significant financial impacts on communities through lowered property values and flooding due to the sewage overflow events. Who monitors Enterococcus in New York City? Again, this is a major barrier to us enjoying our harbor and our waterfront. So the New York City Department of Environmental Protection does mid-channel measurements throughout the 5 boroughs. But again, that mid-channel, that's not necessarily where recreational users are getting out and touching the water. It's not necessarily where primary contact is happening. The New York City Department of Health and Mental Hygiene tests public beaches during recreational season. Surf riders similarly test surfing beaches for bacteria concentrations. Nonprofit organizations such as Riverkeeper test throughout the Hudson and its tributaries. Similarly, the Long Island Sound has their big water quality study that tests in parts of Queens. And finally, the group we're all kind of here to talk about is the Community Water Quality Testing Program. And we test throughout the 5 boroughs, typically at informal waterfront access points, with the help of local partners and community scientists. So we have a video about the CWQT program. It's about 7 minutes long. And we are going to share the link in the chat so you can watch it on your own screen, so we don't need to deal with kind of any lagging or skipping around. So Anna just put the link in the chat, and you guys can open that up. We will come back here in 7 minutes, which should put us at 12:19. So I'll see you guys all back here in a second, and enjoy this little history of the water quality testing program brought to you by one of the founders, Rob Buchanan.
For those of you that just joined, we're watching a video right now. I'm putting the link in the chat. We're going to meet back here at 12:19. This is an opportunity to watch this short video about the history of the CWQT program, but without having to worry about like our screens getting choppier or internet or anything like that. So go ahead, watch the video, and we'll see you at 12:19 to keep talking about water quality.
So it's 12:19. We'll give it maybe just one more minute to make sure everyone has a chance to finish up. Calling you all back to the Zoom meeting. Let us know in the chat if you're done watching the video and if we're ready to get going. Awesome. Thank you guys. Great. We hope you enjoyed. And we will kind of go over what was just discussed in the video and the slides. So if you missed, the last couple seconds, you can always go back to it as well, but we'll kind of start to cover that now. Thank you all. Great participation. Wow, I love it. I hope you guys all have a lot of questions for later. So what is the community water quality testing program and why do we do this? You heard a lot about that in the video just now, but it's really inspired by a lack of access to water quality data, specifically regarding sewage overflow in New York City's harbor. So in 2011, it was launched by the New York City Water Trails Association in partnership with the River Project. Nancy and Rob were the founders. You can see them on the top right over there. And after a brief pilot study in 2012, in 2011, which only included 12 sites, the next year, the program went on to sample 26 sites and was supported by 2 labs. And since then, we have sampled at over 125 unique locations with 17 different partner labs. And we'll go over this again in Anna's part of the presentation, but the way the program works is on Thursday mornings for 20 consecutive weeks during recreational boating season, samples are collected by community scientists, students, paddlers, partner organization staff to measure weekly Enterococcus data. So just a little bit about the growth of the program since the last 12 years. So back in 2011, we started with 12 sites, and this year we are up to 88. We are back above pre-pandemic numbers. The COVID-19 pandemic really impacted the capacity of the water quality testing program because so many of the labs we relied on were schools and universities. So just access to those labs became really different. And the sites, we can see that in kind of the number of sites that are processed and also the lab partners that we have over time. So at most we've ever had 12 labs working together on this. This year we have 11, and it's kind of this jumble of the same 17 labs coming back and forth from years past. Number of tests every year, we can see we have really kind of, again, this year we are surpassing our COVID-19 numbers finally, our 2019 numbers. If everybody submits their samples as planned every week, we will process over 1,500 CWQT Enterococcus samples this year, which is more than ever before. So thanks everybody for all your participation. It literally could not happen without you guys. So fantastic to collaborate all together. Here is just a little site map. We could share a link to this in the chat as well. The yellow markers indicate past sites that are no longer being tested, and the blue markers indicate sites we are sampling this year. There might have been a couple added on in the past couple weeks that should be added in, but for the most part, this is a good stop for understanding where we've tested and what that data looks like. And Anna just dropped the link in the chat. And I'm going to pass it back over to Anna to talk about how the program works.
Yeah, so as Cody mentioned, and as was mentioned in the video, every week for 20 weeks in the recreational season, folks go out and collect 100 milliliters of water on Thursday mornings. You can see on the left-hand side, people do this in all sorts of ways by going over the sides of piers or docks or over the edge of a boat, or sometimes even getting into the water to get the sample. Again, we really couldn't do this without all of you, without our samplers and without our partner organizations who do a really fantastic job of helping us to recruit and maintain samplers across the season. Once samplers go ahead and get these samples for us, they take them to one of their local labs. Next slide, please. And again, we couldn't do this without the partnerships of the 11 labs or 17 labs across the last couple of years. The labs are really the heartbeat of this. They're the people that take the samples, analyze them, and then send out the data. So thank you to all of our labs for helping with this. Slide. So what do the labs actually do once samplers have brought their sample into the lab? As you saw in the video, we take that 100 milliliters of water, we dilute it with some DI water, which is just a special type of water we use, and we feed it a reagent. And the bacteria will eat that reagent and it'll actually make them glow. So we feed them the reagent, we put them in those quantitrays, and we put them in the incubator for 24 hours to let the colonies develop. There's a couple of things that we do along the way to make sure that we have the most robust data and that what we're giving you guys and telling you guys is as accurate as possible. So one example of this is something called a lab split, which is where you take one sample and you split it into two and you test it 2 times. And those 2 tests should have the same results because they came from the same sample. If they're not within about 30% of each other, that tells you that something potentially has gone wrong in your processing or in your lab, something's wrong with your reagent, and you have to go back and check. Another thing that we can do to make sure that everything is working correctly is we can do a blank, which is where you just take plain water and you mix it with reagent and you run the test. And if that blank sample glows under UV light, something has gone very wrong. You have Enterococcus in your water or something else is weird. So it's another way just to stop and make sure that everything is working correctly. Certain labs will also do an Enterococcus quality control, which is where you take a little pellet of dried up concentrated bacteria that you know the amount of, and you mix it into water and you run your test. And because you know how much is in there, you should have a specific amount that you read at the end of all of this. And if those amounts are different, it tells you that you've potentially done something wrong in your processing or something is wrong with your reagent. And again, it gives you an opportunity to go back and review your samples. So these are all things that we do to make sure that the data we're giving you is as correct as possible. Next slide, please. So once those samples have sat in the incubator for 24 hours, those bacteria are fed, they're happy, their colonies have grown. We put them under a UV light, which you can see in the middle picture. And then what we do is we count the number of squares that glow in that blue color. So we count the number of large squares and the number of small squares. And then we look at this handy chart that we can use to tell us how many colonies of bacteria are in the water based on those numbers. And then we go ahead and we send all of this information out to you all in our newsletter on Fridays. So before we kind of move into the data and what it means so far, I just want to stop and take an opportunity to see if anyone has any questions for us so far. I saw one person ask if we compare data with other organizations such as Hudson River Keeper, Bronx River Alliance. So we actually work with them as part of our network. So they're all part of the CWQT network, and the data that we collect, we also get from them, and we publish in our our master data sheet as well in our newsletter every week. So as we go through this, the data that I'll be showing you is actually from not just Billion Oyster Project, but from all of these organizations within the CWQT network. Is there any other questions? Yeah, when you process the samples, you want sample in each of the squares to make sure, yeah, that you can, that you're counting everything. Lee, I see that you have your hand up. I can unmute you.
Hi, yeah, thanks for doing this. This is great. I remember in past years asking Rob for some more behind the scenes information and getting some, and so I'm really happy you're holding this. In a past, a couple years ago, with the lab that I was delivering samples to, the person running that testing, who's not running it now, had mentioned, I had asked her a question about the Enterococcus results, and she had mentioned something like, you know, day to day, hour to hour, the bacteria levels can fluctuate wildly. And I was wondering if that's true, and how does that affect sort of the, you know, accuracy of the results of, or how you report things?
Yeah, that's definitely something to really keep in mind with these is that what we're getting is like a snapshot of what's happening in the harbor or at a given site. And also these results are 24 hours after we've actually taken the sample. And so even though 24 hours is like the fastest that we can possibly do this, it's still not going to tell you, you know, at that exact moment that you maybe want to go get in the water. It's not going to be exact. So this is definitely something to keep in mind, and something to think about. So like, we learned, and as we'll see, that there, you know, there's a correlation between rainfall and bacteria levels. And so if our results say it's green, but it hasn't rained all week, and then it goes and rains and you want to get in the water, you know, maybe think about what those local effects of like rainfall might be. Cody, do you have anything you want to add to that?
Also, when looking at the data, you really don't want to just look at the MPN of Enterococcus alone. You do want to think about the rainfall numbers and the time of the tide that the sample was taken to. So all of that really goes into understanding the samples accurately.
Yeah. Gary, I see you have your hand up.
Hi, how you doing? Thank you guys for doing this. This is amazing. It's a wealth of data that I'm trying to understand and fit in my brain and then figure out how to add to it. I'm also captain of the Gowanus Canoe Club. Our favorite super fund is very much impacted by CSOs, especially at the moment. We've had a couple of fish kills in the past month alone. And we are getting a testing unit that will field test dissolved oxygen, pH, temperature, salinity, and there's a few other things, conductivity and a bunch of other stuff. I don't know what it is, but it's all important to you scientists. Is there a way for us to be able to use this data to substantiate or advocate for your historic data to try and make this information a little bit more real-time, current, so that we can fill in the gaps between the weekly testing and understand how rainfall can affect our water quality within hours or minutes.
Absolutely. So there's a lot of different things that can be done. There's, for example, programs and models that can be built where you look at historical levels of Enterococcus along with you know, the parameters that you mentioned, things like dissolved oxygen, nutrients, conductivity, sort of all of those different things, and look for correlations between them. And you can actually build models to basically get real-time predictions of Enterococcus based on other parameters. So there's definitely a lot of really cool things that can be done with this data. And I think that's one of our hopes, is that people do take it and go the next step and say, what can we do or what can we say with it? So I think you're totally on the right track, that there's a lot of really interesting things that can be done or said when you kind of combine this Enterococcus with a lot of other data. I'll talk a little bit about some linear modeling that I did, looking at precipitation and a couple of other factors, but having equipment like you're about to get, which gives you this whole range of really interesting things, you can say some cool things about, you know, making predictions. So yeah, absolutely.
Awesome.
Thank you.
A couple more questions in the chat before.
Yeah. So if you see a high number of Enterococcus, what actions do you take? Cody, do you want to take this one?
If you see a high number of Enterococcus, what actions do you take? You really need to think about your own health. You know, a lot of times high Enterococcus numbers won't impact a healthy person. But if you have recently undergone chemotherapy or if you have some type of autoimmune disease, you know, that high Enterococcus level might mean that you don't want to go out and recreate in our waterways that day. Other things, you know, you can start advocating for cleaner and healthier waterways. Really, once you notice those higher results, city agencies have an obligation to create swimmable and fishable waterways as per the Environmental Protection Agency's Clean Water Act. So, you know, when you see those elevated numbers, it's kind of like, will this be harmful to my health? And also, oh, is it time to advocate for cleaner water? And we can talk more about some action items at the end of the presentation as well.
We'll definitely get more into like, what can you do? I see a question about the green and red band images at the end of the processing slide. So we're going to talk more about what that means, but very quickly, green signifies safe for primary contact, which is swimming, surfing, boating, things like that. And then red is unsafe. And then yellow is unsafe if conditions persist, but we'll talk about what that means in just a minute. I see a hand up, Anne.
Hi, yes, thank you. Amazing, interesting work. I was a few years ago, I did water quality testing, helping out with the Cornell Marine Extension Program on Long Island. Do they ever like contribute their data to you? Do you ever work with them?
So not currently. We really focus on sort of 5 boroughs and New Jersey, but we welcome data from really anyone. We've picked up new sites this year from folks that were already doing testing, and they were like, sure, you can publish the data, like anything to get it out there and into the world. So while we haven't worked with them, we're definitely, I think, open to talking with them about their data and presenting it and things like that.
Okay, thank you.
Thank you. All right, so these are all awesome questions. I'm so glad everyone is so engaged. We can go ahead now and maybe talk about what the data has shown us so far. So we had a good question, which is, what does green and red in your figures mean? And so green tells us that we have a number of Enterococcus colonies less than 35. And according to the New York City Department of Health standards, if it is less than 35, it is safe for primary contact, which is basically if you're going to accidentally get water in your mouth by, you know, swimming, falling in the water, surfing, things like that. Yellow is unsafe if the conditions persist. And so you would want to see what the mean over a period of time is to decide if you wanted to get in that water or not. And then red is unsafe for primary contact. So this is when you have a value of bacteria in the water that's over 104. So when we look at 2023, which is all the way on the left-hand side, we can see that almost 50% of the time, the water is actually safe for primary contact. Whether that's good or bad depends on if you're a glass half full or half empty person, but I like to think it's half full. 50% of our samples are coming back clean to swim in, which is really great to hear. You can see that about 35 or so % are unsafe for swimming, and then about 20 are unsafe if conditions persist. When we compare this to 2022, we can see really clearly that 2023 has more clean samples and fewer unsafe samples. And comparing this across the last 10 years, 2023 is also coming out looking to be much better for primary contact compared to the past 10 years. Next slide, please. So when we look at all of our sites, again, there's 88 sites within this network. 5 are actually 100% safe so far this season. And those are in the Hudson River, Piers 26 and Pier 40. And then in the East River, we have Brooklyn Bridge Park, Pier 2 Kayak Dock, Gantry State Park, and then Dumbo Cove, which you can see in the picture on the right, which was taken by one of our samplers. Next slide, please. The sites that are have come up as only being red or unsafe are Prospect Park Lake, in the Rahway River, Riverboat Park, and the Sewage Authority, Meadow Lake, and then in the Gowanus Canal, the Lowlands Nursery. And you can see a picture of Prospect Park Lake on the right-hand side. One thing to keep in mind is that 2 of these on the list, Prospect Park Lake and Meadow Lake, are lakes that don't have CSOs in them. And so how do you get such high Enterococcus levels? As Cody mentioned at the beginning, you can have Enterococcus from goose poop. And so these lakes are just kind of filled with goose poop, and that helps to drive these high Enterococcus levels. Next slide, please. So in addition to looking sort of at the percentages of safe or unsafe to swim, I also built a couple of models to try and see if there were correlations between the amount of bacteria in the water and different factors such as the amount of rainfall in previous days, the tide, the month that was sampled, and the water bodies. And what I found was that there are correlations between the amount of bacteria in the water and the amount of rainfall in previous days. So specifically the day of collection, the day before it was collected, and then the previous Monday. We also see that there's a correlation between the total amount of rainfall in the week and the amount of Enterococcus in the water. We see that there were lower levels of bacteria in May and higher levels in July and August. And we also found that specific water bodies were associated with having higher or lower levels of bacteria in them. Something interesting to keep in mind is that, you know, we've had very little rainfall so far this season, or especially in May. We started to get some more in June, July, August. So we've had very little rainfall, and that's one thing to keep in mind is that can as we saw, rainfall can lead to combined sewage overflow, which leads to Enterococcus. So our levels might be lower than normal because of that. Next, our rainfall data, comes from Central Park. So another thing to keep in mind is that because it's coming from Central Park and it's not those specific sites, the correlations might be a little bit off. Next slide, please. So let's go through. I've analyzed the data for all of our different water bodies. And instead of going through everyone individually, I think that what we'll do is we'll let people call out the sites that they care about, and we can go over the data for those sites together. So we can do a couple of these. Cody, if you can go to the next slide, please. So the first thing I want to do is make sure everyone can read and understand the graphs that I'm about to show you. So the top graph is showing the trend of the most probable number of Enterococcus colonies. That is what MPN stands for, across time. So you can see time on the bottom axis and the most probable number of Enterococcus colonies is on the left. On the bottom graph, it's the total amount of rainfall across the season. So the bottom axis is time, and then on the left-hand side, that's the amount of rainfall in Central Park in inches. A couple of things to keep in mind about this are that the data that I'm showing you here is what's called untransformed data. So this is the raw data showing you the actual values each week. This is a little different than the data that I fed to the model. This is just because when you're doing modeling work, you want there to be the least amount of variability. And so you do something called a transformation, which kind of crunches it all down into something more manageable. So when we're looking at this, we might be able to pick up some of these trends that we talked about with rainfall. So you can see in this figure, there's definitely some clear trends with the rainfall and the bacteria, but because of the way that we did the modeling, it might not always show up. Next slide, please. The other figure that I'm going to show you all for each site is these bar charts. And what these bar charts are showing you is the percentage of samples tested that are red, yellow, or green. So safe, unsafe, or moderate. The top figure is going to be all of the sites individually. The middle is going to be all of the sites in a water body together. And then the third or the bottom is going to be all of the CWQT sites. So we can kind of compare what the individual sites are and then compare it to the whole water body that we test and then compare it to all of our CWQT sites. All right, so we had a couple of ones that were called out. Let's maybe do this alphabetically so it's easier for Cody to get to them. Let's start with Coney Island Creek. So Coney Island Creek, we have two sites that we test for Enterococcus. Those are Calvervaux Beach and Kaiser Park. The samples from this water body are processed by the Billion Oyster Project and the IEC. When we look at the top graph, we can see that generally speaking, especially in the beginning of the season, these values are low. So they're less than 10 MPN, which is the minimum that we can measure. And then it goes up to at some point above 24,000, which is the maximum we can measure. So there's definitely a pretty broad range in what we're seeing. When we look at the median for Coney Island Creek, or basically what the middle number of Coney Island Creek is, it's 343 MPN, which is high, and that is above what is safe to swim. We can see that these levels get higher toward the end of the season, where they stay low and fairly stagnant early on, which matches what we talked about with rainfall increasing as we move through the season. When we compare these sites with the total weekly rainfall, we can see that definitely toward the end, there's that big correlation with that big spike in rainfall. So we do see some of these trends holding true. Next slide. When we look at the percentages of what's clean and what's dirty, you can see that Coney Island Creek is generally dirtier or less safe than all of the CWQT sites together. About 50% of them are red or unsafe. Certain sites like Calvervaux Beach has, much higher levels of unsafe than Kaiser Park, but generally this is going to be dirtier or less safe to swim in than all of the CWQT sites this season. Next slide, please. Comparing it to 2022, what we see that's interesting is that so far 2023 is cleaner. So it's not, the cleanest sites of all, but 2023 does look better than 2022. There's fewer of these unsafe and more of these safe days to swim. So this does match with what we saw with the rest of our data. So 2023 for Coney Island Creek is looking good so far, but keep in mind, we still haven't gotten really heavy rainfall yet. So TBD. Let's go ahead. I think Gowanus Canal was next.
There's a question from Lee, who is a Coney Island Creek sampler. So
yeah, go ahead, Lee. Let's unmute you.
Hi, again, this is great. Thanks so much for these graphs and results and just helping to better understand what the results are for the sampling. I actually didn't realize that someone was sampling. So I do Kaiser Park, I guess, and I guess I didn't realize someone was sampling at the Calvert Vaux side. But I think I just wanted to follow up with my prior question when we talked about that in some ways we get just a snapshot. Like partly why I was asking that is to be able to say, express clearly to community members who might ask me like, so how's the water? Should I not go in? And I guess even though we get a snapshot, am I right to think that talking about the trends of the waterway is that it trends towards, the bottom end of quality for our waterways? Would that be the right way to say it, or is there another way to say it, or what would be the best way to kind of express that back to the rest of the public and community members?
That's a really good question. And I think that there's a lot that goes into that. It's not just about what the data says itself, but also about how do we talk to people about that, and how do we do it in a way that makes them care while also being, honest and using the science. And so I think that there's a lot that goes into that and a lot to think about. I would say definitely, you can look at the bigger trends and show that Coney Island Creek, there's two sites. We're not talking about the whole entire water body, but at least at these two sites, the trend is definitely that it is dirtier than the rest of all of the sites that we're looking at across the harbor. And so, we do have years of data going back. And so you could certainly look at 5 or 10 years of data within this creek and see what's going on and what the trends tell you. I think that we can compare 2023 and 2022, but looking at the long term, I think would be really useful if you're trying to say something big picture. Cody, do you have anything that you'd want to add?
No, only that we just have 10 minutes left.
Okay. Let's do Gowanus quickly and then Newtown Creek quickly. And if anybody in this call like has a water body that they're curious about, I can certainly stay on a little bit later and we can chat, or you can always email us. But I do want to get through the rest of this, but I'm so glad everyone is so engaged. Okay. Let's look at the Gowanus Canal. So we're looking again at rainfall on the bottom and the most probable number of Enterococcus on the top. You can see that across the start of the season, the values are fairly low. However, when we look at the median value of the Gowanus Canal, that median value is 272, which is higher than it should be. So even though it looks low compared to these high numbers toward the end of the season, the levels are still too high to be getting in the water. There's definitely a clear, early on when there's less rain, the numbers are lower. When there's more rain, those numbers are higher. And so that definitely stands out from this figure. Next slide, please. When we look at the percentages of what's safe or not safe to swim in, you can see that these are pretty much unsafe to swim in all the time. You can see that compared to the rest of the sites that we have this year, it's very, very unsafe as far as our percentages of samples. So, 75% of these samples are coming back red, compared to just about, 50% or so, or less than that, sorry, 20 something, 30% for all of our sites. So this water body, as we kind of know and can predict, is not as great as it probably could be. Next slide. When we compare this to 2022, the results are actually worse for 2023, which is not within the trends that we see. So all of our sites are coming back pretty red compared to 2022 and compared to all of our CWQT sites. So not particularly surprising, especially given kind of what we know about what's been going on in the canal, but definitely good to see it represented. Let's go to Newtown Creek next.
And y'all get a little preview of all the other data we have as well.
Yeah.
What were Newtown Creek?
Yeah, so Newtown Creek, these sites are processed by Billion Oyster Project. You can see that there is a little bit of correlation between rainfall and the amount of Enterococcus in the water. You can also see that there's some trends with higher levels in June and July. Generally speaking, these levels are high, even though it looks like there's some dips and some highs there. Those lows are still high. So those lows are still within, the 200 or 300 level of Enterococcus. And so it's not great water to be getting in. Next slide. When we look at the percentages of what's actually safe or unsafe, there are definitely some sites that are better than others. So English kills or Dutch kills are, have much more of these unsafe, whereas the Pulaski Bridge and Apollo Street have higher percentages of green. Newtown Creek sites sort of pooled together compared to all of our CWQT sites has fewer safe days and more unsafe. And so we would say that Newtown Creek is probably a little bit dirtier compared to the rest of our waterways that we test. And again, that's not particularly surprising. Another thing to keep in mind is that a lot of these sites that we're sampling them because we know they're dirty. And so a lot of our results might seem really, really bad, but we kind of expect them to be because we're going into places that we know are bad. So just take that with a grain of salt as well. Next slide, we can compare it to 2022. And when we look at these compared next to each other, 2023 on the right-hand side definitely is much greener. It has more swimmable days compared to 2022. But keep in mind that we don't have our big rainfall yet. So, overall, compared to the rest of the sites, it is not doing great, but compared to how it was doing last year, it looks pretty good. We have, I'm sure, other sites that we can be looking at, but we're running really low on time. So let's go ahead and kind of move on to the next section of this presentation, Cody. Go to the takeaways. So big takeaways for everyone. So far, 2023 has been cleaner than 2022 on average. However, we're not in big storm season yet, and we've had less rain this year than normal. So normally in June, we get 4 inches of rain. This year, we got 1.62 inches. And so that really can have an effect on what we're seeing. We saw with the models that there's a correlation between MPN and rainfall. We can see that as well when we looked at those different graphs for some of these sites, with higher levels of bacteria occurring in July and August, which correspond to more rain. Overall, CWQT sites are suitable for primary contact almost 50% of the time, which again, as a half glass full person, I think that's great. And then the best and worst sites are unsurprising. So we know that parts of the East River look really good and are generally, quite swimmable, and that shows up in our data. Whereas sort of the usual suspects for water that you don't want to get into, Gowanus Canal, Rahway River, Newtown Creek, maybe sites that have little tidal influence or drainage, those that have legacy pollution, those are going to tend to be worse. Next slide, please. I will leave time for questions at the end. I do want to let Cody talk a little bit about what you can do. So Cody, I'll let you go to the next slide, please.
Good thing. So there are always questions, what can we do about this Enterococcus problem? And the biggest thing is really not adding more water into the combined sewage system during wet weather events. So the New York City Department of Environmental Protection, who is kind of in charge of dealing with the CSO problem, their latest campaign is the DEP Wait app. So you could actually take your phone right now and put it up to your computer screen and scan that QR code in the top right, and download the Wait app. It's going to use your geographic location to determine what wastewater treatment plant your home is in, or your job, wherever you set it to. And then it will send you updates and alerts if you should be trying to save water during a wet weather event due to an overload of the combined sewage system. I don't think there is a website version, but you should be able to look up other waterway advisories and things like that to understand CSOs in your neighborhood. Definitely poke around their website. Another thing you can do, also looking at the Department of Environmental Protection's long-term control plans. Those are really their action plans of how they're going to manage the combined sewage overflow waterway by waterway. At this point, I think every waterway in New York City has one. Definitely familiarize yourself with the plan and think about, ways to advocate for something better. Big opportunities in maintaining local green spaces, bioswales, rain gardens, all these things absorb stormwater. And because of that, they're taking that water out of the sewage system and preventing the pollution overflowing into the harbor. So making sure that bioswales are well taken care of, that tree pits can absorb water, all that type of stewardship is very helpful. Newtown Creek Alliance does really great work in their neck of the woods around Greenpoint. Similarly, look out for rain barrel giveaways from your local state senators and council people. Setting up a rain barrel to collect some runoff from the gutters around your home or apartment. Also a really helpful way to keep water out of the combined system. And then finally, like a simple don't litter. Anything that you see kind of on the streets that gets swept into the catch basins and into the sewage systems during rainfall. So whether it's picking up pet waste or any other type of debris, that's definitely going to stop kind of the impacts on the unsightliness of the harbor. And finally, of course, get involved with the community water quality testing program. You can become a sampler. You'll get trained to sample 20 weeks of the year from April to May. And we can set you up for next year with a sample site of your choosing, perhaps. And of course, stay in touch. We have another QR code here on the screen to subscribe to our newsletter. And I think Anna will put the link in the chat. We send out emails every Friday to give you our most up-to-date Enterococcus data that we have. It comes from all of our partner labs and covers the 88 sites throughout the city. Also puts you in touch with potentially other events happening throughout the harbor. Another thing that we do at Billion Oyster Project is we have a symposium. This is an opportunity for community scientists and advocates to showcase the work that they do. Again, sign up for our mailing list and we will send out the open call for that later in the year or early next year. And then upcoming CWQT events. If you guys want to hang out, get to know each other more, we're going to have our end of season party on October 19th from 6 to 8. So mark your calendars and we can all hang out and chat more. And yeah, any other questions, you can follow up with water quality at billionoysterproject.org. With 1 minute to spare. Any other last questions?
So first, I just want to say thank you to all of our samplers. First of all, huge thank you to our samplers, because without you all, this would not happen. So thank you for taking time out of your Thursday mornings to collect samples. That's so awesome. I also want a huge thank you to our partner labs, because again, without them, this really wouldn't happen. This huge amount of data that we're working with, that we provide you with, are coming from them. And so shout out to them. And thank you to everyone that has funded or supported this over the years. We really appreciate that as well. And with that, it's just about 1 o'clock. So thank you for joining us. I will stick on, and Cody can probably stick around for a couple of minutes to keep answering questions or look at other data sets. But if you have to go, email us waterquality@billionoysterproject.org, and we're happy to chat. Have a great day, everyone.
Thank you all.
All right, so for those of you that are sticking around and want to ask some more questions, where do we want to start? Who wants to raise their hand or pop something in the chat?
Chat got a little crazy there too, so if we missed something and you really want an answer, let us know.
Okay, Ronan.
Hi. I had a couple questions. I don't know if I should just go down the list. Or
Yeah.
Okay. So let's see. The first question was that would you say there are higher Enterococcus? I don't know, because if if Central Park Conservancy collects Enterococcus data and then comparing it to other city parks, because I don't necessarily know exactly how the Enterococcus levels vary from park to park, but I do know that there are quite often a lot of issues with HABs, specifically in Central Park and Prospect Park, and then also in Crotona Park at Indian Pond. I'm not sure if you know any info on that.
Cody, do you want to take that, or?
I have a non-sciencey answer for you, I guess. I'm the resident non-scientist. Sorry, someone's at the door here. Okay. We do test one other lake within parks. We test Casino Park Lake, and the concentrations of Enterococcus there seem to be fairly lower, though I know the lake does have a lot of algae blooms as well. So I think this would probably take a little bit more study to figure out and pin down.
I see. So, because I don't know, do you know if the Central Park Conservancy does any water quality testing or not?
I don't know off the top of my head. I'm not sure. It's not part of our network.
Yeah. I see. And then I asked another question, and Gary had answered it a little bit, but I guess just for a little more context, because I know that because I've been working with the Bronx River Alliance doing their water quality testing along the Bronx River, but we sometimes have these projects called Project Waste, where we go to different sites. We've gone up to 233rd Street in the Bronx, and we take plastic bags, we put on waders, we walk into the river, and then we kind of clean it up and kind of reduce the amount of rubbish and waste and trash and such in there. And I'm not sure if you, because the Bronx River is a little bit cleaner, I'd say, than say the Gowanus Canal or Newtown Creek. But if you were just going to say, oh, I'm just going to wade in with waders in a very polluted water body, are waders enough of a barrier of protection to protect you from all the kind of harmful pathogens and bacteria in the water, or should you take further precautions?
I think it's really a case-by-case basis. You need to know your own health and your own the strength of your own immune system. I'm someone that's fallen into Flushing Creek before, and I'm fine, and I didn't get sick from that. But there are other people that may be going through chemotherapy or have an autoimmune disease, and just getting that water splashed on their skin might cause a skin rash or something like that. So it really depends on your own health and what you're comfortable with. Your average healthy person can take a little splash from that type of water, and it should be no big deal. When we're saying, things are unsafe, we're talking about like putting your face in the water and really like drinking it or getting it in like your face holes.
Yeah.
I see.
And just a quick disclaimer that, you know, I am not a medical doctor. I'm a doctor of geology, so I cannot provide you medical advice. But when we collect these samples and when we stick our hand in the water, we're wearing gloves, which I imagine is probably, you know, about equivalent to the protection you're going to get from a waiter. You know, you get some of your, and it's, you know, most of the time we're fine. And so, like Cody said, it's a personal decision. You have to think about your own health, you know, your own circumstances. But, you know, we get near the water to take the samples and we're wearing some protection. So I think waders are good. Yeah, keep it out of your face holes. Okay, Anne, I see you've got your hand up. Or yeah, let's Anne, and then we'll come back to you, Ronan.
I was just wondering with the oysters, with them being, you know, filter feeders and filtering out stuff, are they filtering out mostly like plankton, and or do they filter out the bacteria and the Enterococcus and everything?
They do filter a lot of different things. They filter, you know, plankton and you know, little things like that. They also filter out nutrients, pollution, heavy metals, like all sorts of stuff. So yeah, they definitely do help with that. We can't necessarily say that our oysters are doing that in particular, but generally speaking, that is correct. Yeah.
Thank you.
Thank you. Yeah, good question. Okay. Okay, back to Ronan. And then we can go to Gary and Atika.
Sorry, I had one more question. I accidentally muted myself. But so final question is, would you say that, because I know there's kind of the talk about using MS4s versus CSOs, and that MS4s are usually better because it separates the sewage. So with water bodies that have more MS4s, I don't know if the MS4s maybe come out the same way as a CSO, or if it first goes to a treatment plant, but if the water quality with more MS4s is usually better. I don't know if maybe that's a question for Ashino Taniko with a swim. I'm not sure.
Cody, do you have any insight there?
If your first thought is to default to Shino, I think that's a great idea. I can't give you a confident answer on that.
Okay.
Yeah, sorry, but it's a great question. So thank you. Okay, Gary.
Hi, just a note on filter feeders. The real workhorses that are able to survive in the most polluted waterways like Newtown Creek, Gowanus Canal, and Coney Creek are Atlantic rib mussels, and those can filter down to 1 micron, which is bacteria level. And there's a big DEP pilot program going on in Bergen Basin where 750,000 rib mussels are going to be submerged in a watertight box, and water quality will be tested on the intake and on the outtake in order to prove that they are a viable biofilter. It's a little extreme of an experiment, but definitely rib mussels and their habitat are a really, really forward way of tackling CSOs. So if anybody wants to jump on that bandwagon, I will happily join you.
Thank you so much for sharing that. Yeah, mussels are definitely super duper important. So thank you for reminding us of that. Okay, Atika?
Yes, hi. My question was if you can go over the data you have collected for, I think I saw Hudson River or Harlem River. I'm not sure which one it was. Thank you.
Yeah. So we have both. So the Harlem River, we have 3 sites. We have Lincoln Avenue, Little Hell Gate, and Water's Edge Garden Beach, and this is processed by the Randall's Island Park Alliance. When we look at the values at the Harlem River, they range from less than 10 up to 1,000 MPN of Enterococcus. And so it's not great. But our maximum value is over 24,000 and the Harlem River doesn't reach that. And so, you know, that's one thing that we can say is that it's not the worst. You can definitely see that there's a little bit of a trend. There are some places where the values of bacteria are higher. There's definitely some correlations perhaps between rainfall. When we go to the next slide, please, if we look at the percentages of sites that are safe or unsafe to swim for 2023, we can see that the Harlem River is about on par with the percentage of swimmable sites for everything we looked at. So, you know, almost 50%, and it's got fewer unswimmable sites. So it has more in that like maybe range. So the Harlem River is actually, you know, looking pretty good so far for 2023. We can compare this to 2022 on our next slide. And we see that compared to 2022, they're very close in their values. 2023, as we saw with the rest of these sites, does look a little bit better. But generally speaking, the Harlem River is safe to get in, you know, 40 to 45% of the samples that we've taken. We also have the Hudson River, and there's like almost 20 sites that we have in the Hudson River. These are processed by the River Project, by John Jay College, and by Sarah Lawrence Curb. The values in the Hudson River are, again, very low, generally speaking, compared to the rest of the water bodies. So it ranges from less than 10 to about 3,600. And so compared to our maximum value, which is 24,000, these are fairly low, and they stay low. And then the median is 20. And so the sort of middle value of 20 is totally swimmable, or safe for primary contact. So when we look across the season, generally speaking, it is safe for primary contact. There is some correlation, even though they're just little tiny bumps, you can kind of see where you do have slightly higher levels of bacteria in the water across the season. And those tend to correlate to these rainfall events that we see in the bottom. When we look on the next slide at the percentages of samples across the season, the Hudson River sites overall are like 65%. The samples we take, 65% of them are swimmable or safe, compared to 50% for all of our sites. And so it's definitely cleaner than the rest of the samples we look at, the sites we look at. And this is definitely borne out on that top figure. You can see that a lot of these sites are almost fully green, or green and yellow for the season. Next slide, please. Compared to 2022, you can see that it's definitely, we're doing better in 2023. Again, you know, totally matches what we've seen with all our other sites, what we've seen with rainfall so far, where, you know, compared to last season, it was, you know, maybe 50 something percent swimmable. This year it's 65%. So overall, our samples in the Hudson River are clean. Does anyone else have any other questions or anything else that they'd like to look at? Yes.
All right, I have one other question, because Lee Patrick mentioned I guess using mussels, but I guess because I know oysters filter, I believe more gallons of water compared to any other bivalve, 50 gallons a day, but I'm not sure if variations in oyster species or other types of bivalves, such as with other mussels. I think there are red mussels and forgetting the other species, but I'm not sure if it's less to do with the different species and more to do with the different bivalve in terms of how much, and maybe the size in terms of how much they can filter, or I guess what exactly?
That is a really good question. I will be honest, off sort of the top of my head, I'm not exactly sure. I can imagine that there are differences between the different species of oysters and how much they're able to filter. As far as like pound for pound, who can filter more and why? That is a really good question that I unfortunately don't have an answer to. Cody, do you know more of the specifics of that? That would be a good question for one of our oyster biology folks. Yeah, if you wanted to email that question to us, we could pass it along to somebody that might be able to give you a better answer than us. Yeah. So the data that we've displayed, can you use that? Yes, of course. So we would love for you guys to use this information. We do this for you. So please take our data. Cody put a bunch of links, including links to the data sheets. If you ever have questions about like, how do I analyze this? Or what does this mean? Or what, definitely, again, reach out to us at waterquality@billionoysterproject.org. And we'd be happy to walk you through that. I see we've got another hand raised.
Yes, hi. So I know I had asked this question during the chat, if you are able to test other pathogens. And I know the person replied saying that we only focus on Enterococcus, but would you know if any other agency focuses on other pathogens, or if the water that you collect, do you forward it to another agency so they can focus on other pathogens? Just trying to figure that part out, that's all.
Yeah, that's a great question. So unfortunately, the way that the testing works, we can't like send them the water when we're done with it. So we definitely, we end up getting rid of that water that we don't test because it's not useful after we've opened up the bottle and it's not cold anymore. But there are other agencies that are looking at things like E. coli. So the Department of Health is definitely very interested in that. The Department of Environmental Protection is going to be interested in those things. I don't know about other nonprofits or sort of these smaller labs, what they do. I want to say that maybe the IEC, I know they do a ton of different tests. So that might be another place to get that sort of information from. Did that answer the question? Okay. Anything else?
I see we have a good oysters versus mussel debate going on in the chat, but I will refrain from comment.
Yeah, I think as the Billion Oyster Project, we probably have to abstain from that particular debate. But I'm glad that everyone is getting so enthusiastic about this. I think that's fantastic. Okay, is there anything else that anybody wanted us to cover in the last couple of minutes? Okay, one more question. Yeah.
Yes, sorry. With this data sites, I guess it's interesting because how do you choose exactly where the sites are located, and I guess what factors involve? I guess maybe it's to do with where it's easy to access the sites in some case, because I know also with the Bronx River Alliance, and we do our sites, sometimes we also sample right where there's an outfall pipe, which in certain cases makes it not very easily accessible. But then with the Hudson River, I didn't see, I think when you were showing the slide, that there were any sites, I think between a little bit below 59th Street and then up to almost 145th. Are there any sites kind of by the boat base in the 125th as well?
So a lot of where our sites are based on just community scientist interest. The way this program started was people just being interested about their particular boat launch or their particular informal access point site. And then those community scientists would go and collect that sample and bring it back to the lab. So if you really don't see something on the map, that just means nobody that's interested in sampling has found out about this program yet. And we'd love to help you kind of get new sites on board if that makes sense for you.
I see, because I know the boat basin is relatively close, and I had tried sampling there before a while back, but then I think they were a little upset because it's private. And so I think that was one conversation. But I think just sort of having sites kind of spread out pretty evenly along the whole river, if it's feasible with, I guess, means and such to get, I guess, more variable data or something to get, I guess, to see how much variety is there between the tides, because the Hudson River flows both ways in a sense, and locations, and if there's also closer to outfall pipes and such, kind of measuring the variations and such.
Yeah, that would definitely be really cool. So the Hudson River Park Trust are the ones that kind of do the sampling along a lot of that. You can definitely talk about that with them. Or like Cody said, if you're interested in potentially opening up some new sites next season, if that makes sense for you and what you're trying to accomplish, definitely let us know. Yeah. Okay, anything else? All right. Thank you all so much for your attention, for being such a great audience. These have been great questions. I'm so happy you all were here for this. And yeah, definitely stay in touch, sign up for our newsletter, and let us know if there's anything that we can help you with your water quality. All right. Have a fabulous day, everyone. Bye.
Hi, everyone. Thank you.